this example looks at dealing with a partial fraction where one of the factors in the denominator is an irreducible quadratic. So we're going to look at an example where we're going to express 5 over x squared plus 1 times x minus 2 in partial fractions. Looking at the example, it's a little bit different from the previous ones that we've tackled because one of the factors, as you can see, is a quadratic which can't be factorized any further. So that makes the first term for the partial fractions a little bit more complicated. The denominator, of course, is x squared plus 1, and because it's of degree 2, that means the top term can be up to degree 1, so it becomes ax plus b. The x minus 2 term is just the same as we've already dealt with. It just becomes c over x minus 2. The next step is just the same as in the previous examples where we multiply through by the denominator. So in this example here, the ax plus b term over x squared plus 1, if we multiply that term by the denominator, the x squared plus 1 bit disappears and we're left with ax plus b multiplied by x minus 2. The term with a c in it, when we multiply through by the denominator, just becomes c times x squared plus 1. And then the steps taken as before are just to try and find suitable values to replace x with, which will allow some of the letters to disappear. So the most obvious suggestion to begin with would be to replace x with a 2, so that this term here becomes 0, which will get rid of the a term and the b term. So when we multiply through by 2, as I said, these bits disappear, just leaving us with 2 squared plus 1, which gives us 5c, leading to c equals 1. Then we need to find another value to replace x with. So we've already figured out what c is, and looking at this bit here, if we replace x with 0, then we're going to get rid of that a term, leaving us the b term being the only thing that's unknown in this example. So when we do that, we get minus 2b plus c. Of course, we already have calculated c. We know that it's equal to 1. So we end up with 5 equals minus 2b plus 1. And rearranging that and solving it, we get b equals minus 2. So we've found c, we've figured out what b is. The only thing left is to figure out what a is. There are no obvious numbers to replace x with, but it's not a problem because in this example all we need to do is pick any number we like for the value of x. So I chose 1 because it's nice and easy to work with. So replacing x with 1 and multiplying through, we end up with a plus b times minus 1 plus 2c. The 2c's came from 1 squared plus 1, which of course is 2, giving us 2c there. We can then replace the letters b and c with the numbers we've already figured out for them. So when we do that, we end up with minus a minus minus 2, which gives us plus 2, plus 2 times 1, which gives us that. And rearranging that, solve it to figure out what a is, we get a equals minus 1. So to finish off the example, it's just a case of replacing a, b and c with the numbers with the values we've figured out for them. So we end up with minus x minus 2 over x squared plus 1 plus 1 over x minus 2. And that is essentially the answer. We could tidy it up a little bit if we wanted to by dealing with this minus x minus 2 term. It's a little bit untidy, and if you're going on to do some sort of differentiation or some other operation with it, it might be easier to work with if we just took a minute to tidy that up a little bit. So I would probably just change the order of this and make that a negative term. Of course, when you do that, you need to take a lot of care to make sure that you get the signs correct here. So notice that this minus 2 over here becomes a plus 2 when you take into account the fact it's been multiplied by that minus. And that would be a good way to leave the final answer.